density, will take here, at 0 degrees Celsius, temperature is what here? 0 degrees Celsius. Density of a certain oxide of gas at 2 bar is same as that of dinitrogen at 5 bar. What is the molecular mass of the oxide? So we have to take an equation in which molecular mass is there. So in which equation, which formula molecular mass we discussed here? Let me see this one actually. So here let me take one slide I am taking here. Now I'm writing over here. Just a minute. Tell me better, temperature is what? 0 degree. Right.
0 degrees Celsius.
Now I don't have a textbook with me. Next, what happened? What is the?
So the density of a certain oxide of a gas at 2 bar.
Just a minute, beta. If I have a textbook here, let me see. Five, 4, yes, 5.4, right. Now at 0 degrees Celsius, a density of a gas oxide at 2 bar, they didn't mention the density, I'm writing the D1 over here, D1. Right, next, pressure P1 I'm taking, pressure is equal to what? 2 bar. And is the same as that of nitrogen at 5 bar. For nitrogen, this is for what actually? I don't know that for X gas. Okay. And the pressure for nitrogen will be what here? 5 bar. What is the molecular mass of that oxide here? So they're asking the molar mass of this X. So that given temperature is constant beta. This is constant. Density also constant. See? The density of the gaseous oxide at 2 bar is the same as that of nitrogen. Therefore, density of X is equal to density of nitrogen. So what are the constant values we got beta? Density, temperature we got the constant. And we have a formula is there. What is the formula? Anybody do remember this formula? Anybody do remember this formula? 5.4 no? PM is equal to DRT. PM is equal to DRT. Anybody remember this formula? Anybody? PM is equal to DRT. Everyone knows this formula? Are you there?
Yes, sir.
PM is equal to DRT formula we discussed or not beta? Tell me that one. We have completed PM DRT. You just go for what happened last classes. PM DRT formula we have derived or not?
Yes, sir.
Now,
Yes, sir.
density is same. So I'm taking P1, a molar mass of X, density D1, and you're taking T1. And I'm taking one more P2, molar mass of what? Nitrogen, D2, RT2. But what they said, temperature same. Leave it this one. D1, D2 same. Leave it this one. R also same here. Okay. Now what will be the formula beta? What will be the formula? P1 mx is equal to, what is the formula beta? P2 m. Now P1 means what? X I am taking. P2 means what? N2 I am taking. Correct? Now Px how much beta? 2. Molar mass of X I am calculating. Partial pressure of nitrogen how much it is? 5. Molar mass of nitrogen, anybody? What will be the molar mass of nitrogen? How much beta?
28.
28. Right. Now molar mass of X will be 5 into 28 by 2. 2 ones are 14. 14 fives are how much here? 70 grams. So molar mass is what? 70 grams per 1 mole here, isn't it? So what is the molar mass of X here? 70 grams per 1 mole. Understood? In this way you have to do. When you write this data, isn't it? We get which formula we have to take here. See, temperature, density, pressure, molar mass. In which formula you are having all these things? PM is equal to DRT formula will contains all these things. Understood here? Now note down everything. Next we'll move to what? Second. Next problem 5.5. Next problem 5.5. Pressure of 1 gram of, what is this 5.5 problem beta? Anybody read? Pressure of 1 gram of ideal gas A. The given what? Weight of, all of you read that one beta. Weight of gas A is equal to how much? 1 gram. 5.5 problem. This one. 5.5. Weight of, I am writing over here. Weight of gas A is equal to what? 1 gram. Next. Temperature 27 degrees Celsius. Next. And its pressure will be how much here? Pressure of A is how much they given? 2 bar.
2 bar.
Next, weight of B gas.
2 bar.
Weight of B gas is given how much beta? 2 grams. Pressure introduced in the same flask and the same temperature is constant. The pressure becomes 3 bar. Okay, the pressure is becoming 3 bar. Means what is the pressure of B? Anybody?
The 3 bar.
What is the pressure of B? 1 only, no. Actually, when you introduced gas A in a container, the pressure is what? 2 bar. Second time, if you introduce gas B, the pressure is becoming what here? 3 bar. So how much difference you got here? 1 bar here. Understood? Actually, you take here. Now this is a container. You are placing gas A over here. Now the pressure is what here? 2 bar. When you place here, what happened? Gas B also. Now the pressure is increased to what here? 3 bar here. Now what is the pressure of B one? What's the pressure of B in this one?
1 bar.
So 1 bar.
1 only, right? Now they are asking what is the relation between the molecular masses. What is the relation? You can't take density formula over here. You can't take PM is equal to DRT formula. Can I take PM is equal to DRT formula here? Is it possible? This formula is useful for you in 5.5 problem? No, because density is not saying about.
Yes.
There is no density here. So shall I take PV is equal to nRT formula? Yes, you can take here. You can take here. Why? Because you see here. Temperature constant. Yes. You observe here. Same temperature. R is a constant. N is not constant. Leave it this one. Volume is constant because they are saying what happens. Same vessel. Same flask they are saying. When you say what happens. Same flask. What happened. Volume also will be constant. Now what will be different here? P and N. P and N are different. So with the PN, by using what PV is equal to nRT formula, now we can write what actually here, everything actually. So I'm writing over the slides over here. See, which formula we are taking beta here? PV is equal to nRT formula, in which I told you temperature constant, R is constant, VV is constant. So in that case, what I can write here, based upon this, to take in this case, I'm doing something. Pressure of what? A. Okay, volume is constant, leave it like that. N is nothing but what? N is equal to weight of A, molar mass of A, correct? Now, write down weight of A and molar mass of A into R constant, T constant, take divide. Next, partial pressure of B, volume. Again, weight of B, molar mass of B into again R. Now, temperature same, no? Cancelled. R is same, cancelled. V is same, cancelled. Now, what is the pressure of A beta? How much they given pressure of A?
2 bar.
2 bar. Right. 2 bar. Pressure of B will be?
1 bar.
1 bar.
1 bar. 2 by 1. is equal to, now weight of A, how much it is weight of A? 1 gram.
1 gram.
Molar mass of A, I don't know. So put as a molar mass of A only. Weight of B, how much beta?
2 grams.
Molar mass of B, we don't know that one beta. We don't know that. Now based upon this, what we can write? 2 by 1 is equal to 2, right? Now 1 by MA. Now send this one numerator like this here. Now what we get here? MB by 2. MB by 2 here. Now they are asking what is the relation between what? Find the relation between their molecular masses. Based upon what I can write here, beta? 2 is equal to MB by 2 MA. Now send this one 2 over here. What we get here? 4 is equal to MB by MA. Now what we can get directly, therefore MB is equal to 4 MA. This is the answer. Or MA is equal to what? MA is equal to 1 by 4 MB. Both will be the answers. Understood beta here?
Yes, sir.
Had any formula beta here? I have seen the data here. Data containing what? Temperature constant. R is always constant. Volume is constant. Only we are having pressure and moles only there. Mole is nothing but in the case of weight and molar mass. So we have to do in this way. So this is about the 5.5 problem. Next we'll see the 5.6 also. Let me take 5.6 now. What is 5.6? Let me see this one. 5.6. A dry cleaner, the drain cleaner, Drain X, contains small bits of aluminium which reacts with caustic soda, produce dihydrogen. Produce what? Dihydrogen. What volume of dihydrogen at 20 degrees Celsius and 1 bar will be released when 1.15 grams of aluminium reacts? So first of all, they're asking what actually, how much amount of hydrogen will be released when 0.15 grams of aluminium reacts with caustic soda at temperature 20 degrees Celsius. All of you please read this question beta. Read this question. Read this question. Now I will do this one actually. Let me see this one problem. Now what I am doing here? Drain X contains aluminium. So I have to write a reaction with what? Aluminium. 5.6 it is. Aluminium. Right. Reacting with caustic soda. Anybody, what is the meaning of caustic soda? What is caustic soda beta? Sodium hydroxide is caustic soda. Now when they react, what happens? We get sodium aluminate, sodium AlO2 plus hydrogen gas will be released. Now they are asking how much amount of hydrogen will be released in this case. They are asking the volume of the hydrogen. The question is what? How much amount of hydrogen will be released? Isn't it? If you take 0.15 grams here. If I take here 0.15 grams of aluminium, understood question here. If I take 0.15 grams of aluminium, how much amount of hydrogen gas will be released? They are asking. Understood? First of all, we'll take STP conditions. Later, we will convert into what? 20 degrees Celsius. Now, let me balance this reaction better. Let me balance this reaction. First of all, we'll balance this one. Now, to balance this one, what we'll take here? I will take, if I take 2 moles of alumina, here also we get 2 moles of alumina, right? If I take 2 aluminum, here also we get 2 aluminum. If we get 2 sodiums here, put here also 2 sodiums. Then, how many hydrogens we got here? 2 hydrogens here. Here, how many oxygens we got here? 2 to the 4 oxygens we got. 4 oxygens, how many we are having here? Here 2 we are having, here only 1 we are having. Put here 2 here. Now, 2 oxygens, here 2 oxygens. Total what happened? 2 to the 4 oxygens. Now oxygens are balanced here. Now let me see hydrogens, 2 to the 4 hydrogens plus here 2 hydrogens, 3 into 6 hydrogens. Therefore put here 3 H2. Now this is balanced here, right? Now here the question is what? According to this equation, 2 moles of aluminum. Shall I write like this? 2 mole of aluminum reacts to give how many moles of hydrogen beta? How many moles of hydrogen? 3 moles of
3 moles.
3 moles of hydrogen.
3 moles of hydrogen.
2 moles means how much beta? 2 into atomic mass of aluminum, how much? Anybody? 27, right? Okay, 1 mole carries how much weight beta? 1 mole of aluminum carries how much grams of aluminum? One mole of aluminum carries how much beta? 27 grams. 2 moles will have how much? 2 into 27 grams. How much it will be? 54 grams. Now, 4 grams of aluminum gives how much amount of hydrogen beta? 3 moles of hydrogen. Correct or not? 3 moles of hydrogen.
6 grams.
6 grams per 3 moles of hydrogen. Right? So 54 grams of aluminum is giving 3 moles of hydrogen. Correct? Now, if how much weight they are asking to take here? How much weight they are asking to take here?
0.15 gram.
Now take a cross multiplication, 0.15 grams of aluminum. Generally, 54 grams of aluminum will release 3 moles of hydrogen based upon this equation. 2 moles of aluminum is equal to 54 grams beta. 2 moles of aluminum is equal to 54 grams. Now 54 grams of aluminum is releasing 3 moles of hydrogen, then 0.15 grams of aluminum will release how much amount of hydrogen? Now we'll take 0.15 into 3 divided by 54. Okay. Now if we cancel this one, how much we get here? Shall I write like this one? 15 into 3 into 10 to the power of minus 2 divided by 54 it is. 3 ones are, here also 3 ones are, 24, 8s are, 18s are, 15 by 18, how much beta? 15 by 18, 3 5s are, 3 6s are. Now 5 by 6, how much? 5 by 6 means what? 5 by 6 is equal to
8.
Exactly, we have to take 5 by 6 is equal to 0.83 beta. 0.83 into 10 to the power of minus 2 moles. Into 10 to the power of minus 2 moles. But shall I write like this one for our understanding? 8.3 into 10 to the power of how much it is? Minus 3 moles. Shall I write like this? Both are same only. Now what I am saying, 0.15 grams of aluminum will give 8.3 into 10 to the power of minus 3 moles of, isn't it, hydrogen gas. But what they are asking in terms of volume, they are asking. Question is what? What volume of hydrogen? They are asking volume of the hydrogen, they are asking. Volume of the hydrogen, they are asking. Okay, at what temperature? 20 degrees Celsius. At 20 degrees Celsius. But you know one thing, at STP condition, 0 degrees Celsius, you know one thing. 1 mole occupies, 1 mole is equal to what? 22.7 liters you can write here. Or 22.4 liters you can write. But that is STP condition at 0 degrees Celsius beta. But it's what temperature? 20 degrees Celsius. 20 degrees Celsius, you can't take this formula. This you can't take it. Okay, if 1 mole carries 22.7, then how much it is? 8 into 10 to the power minus 3. You can't take this cross multiplication because it's 0 degrees Celsius. When they give 0 degrees Celsius, you can take this one. 1 mole occupies 22.7 liter, then 8.3 into 10 to the power minus 3 occupies how much? That you can't take because if it is 0 degrees Celsius, you can take. So what I mean to say here, you take what? PV is equal to nRT formula now. All of you take what? PV is equal to nRT formula now. What is that formula? PV is equal to nRT formula. PV is equal to nRT formula. Right? Now let me see here what happened. Pressure how much given beta? What we are calculating? Volume, no? Volume is equal to nRT. Now, Tell me, Bada, how many moles we got actually? 8.3
into 10 to the power
minus 3. R value, when you read the problem here, the problem saying that what happened? 1 bar pressure, correct? 1 bar pressure, what happened? R value also in terms of 1 bar. Means in bar, what is the R value beta? Because pressure we are taking 1 bar. R also should be taken in bars only. In yesterday class, I told you what is the R value in bar. What will be it is? 0.0831. If it is in atmosphere, 0.0821. If it is in calories, 2. If it is Joule, 8.314. Into temperature, how much given? 20 is given, but I have to take 20 plus 273. That is equal to 293. Right? 293 we have to take. Divided by pressure, they given 1 bar, so put as pressure here. Now, if you do the calculation part, we get the answer better. So take this one, what? 83 into 10 to the power of minus 4. You take this one, 831 into 10 to the power of minus 4. And multiply 293 this one. Multiply 83, 831, 293 into 10 to the power of minus 8. Okay, you will get the answer. Okay, you do that one later. Okay. What answer you get? To tell me later. In this way, we can do the problem. Right? Next problem. 5.7. Shall we take 5.7? 5.7 you can do, no, I think.
Sir, yesterday it
We
was
have done yesterday.
We have done, I think. We have done. 5.8 also we have done.
no, sir.
5.8. Let me see 5.8 now. 5.8. What will be the pressure of the gaseous mixture when 0.5 liter of hydrogen at 0.8 bar pressure and 2 liters of dioxygen at 0.7 bar pressure introduced in 1 liter vessel? What will be the pressure? So first of all, we'll make this here. What is the question, beta? 5.8. Just what will be the pressure of gaseous mixture? They're asking pressure when for hydrogen volume is equal to volume of the hydrogen is equal to how much here? 0.5 liter. Next, pressure of the hydrogen. They're asking P total, right? Pressure of the hydrogen is equal to 0.8 bar. Next, for oxygen, volume of the oxygen is equal to 2 liter. Next, pressure of the oxygen is equal to 0.7 bar. No. And volume is equal to the given here. Total value. V total is equal to how much they given? Total volume is what? 1 liter. 1 liter. The volume is given here what? 1 liter. Now they are mixing these two items. When they are mixing, what happened? What will be the pressure of the gaseous mixture when they are mixing these two? When they mix these two, what happens? When they mix these two. Now in this case, I can't use the Dalton's law. I cannot use the Dalton's law. Why? Because what is Dalton's law? P total is equal to mole fraction of what? Hydrogen. P total. Sorry. Partial pressure of hydrogen. Partial pressure of hydrogen is equal to mole fraction of hydrogen into P total. But because mole fraction we can't take here because number of moles are not given. No. When we take mole fraction beta, if moles are given, if weight is given, if mass is given, we can take mole fraction. So which formula we have to take in this case? So what I'm doing here, I will take normal formula P is equal to nRT formula. P is equal to nRT. Now the based upon this, I'm writing a pressure of the hydrogen. Volume is constant, put like that only. Next here, what happened? Number of moles is not constant. I'm putting number of moles of hydrogen. Next, what happened here? R is constant. Temperature, I think, also constant. No problem. V is 1 actually. V is equal to 1. So we can put that one over. Similarly, I can take pressure of what happened? Oxygen. volume, number of moles of oxygen, again R and T. Now what is the, based upon this can I write number of moles of hydrogen is equal to what beta? What is the formula for number of moles of hydrogen here? Partial pressure of hydrogen into V divided by RT. Next, number of moles of oxygen is equal to what beta? Partial pressure of oxygen into V by, okay. So what I am taking here, so we need actually total pressure, right? We need total pressure. Now what we'll do here, so we'll do one thing. We add these two because it's a mixture, no? Because we are adding these two, no? In this problem, we are adding hydrogen, oxygen. Now, number of moles of hydrogen plus number of moles of oxygen is equal to how much beta? Partial pressure of hydrogen, the pressure of hydrogen, partial pressure of hydrogen into V by RT plus partial pressure of oxygen into V divided by RT. Now, if we add these two, what we get? Total number of mole size. Now again, we'll take PV is equal to nRT formula here. Based upon this PV is equal to nRT formula I have taken for individual gases here. This is for what? Individual gases, for hydrogen and for what happened? Oxygen. Now this PV is equal to nRT for what? For what purpose I am taking? For mixture I have taken. This is for what mixture? For what? Both hydrogen plus nitrogen. Now P total, they are asking P total only, no? So P total is equal to mixture of what? Hydrogen plus nitrogen. And volume, total volume is what? V total will be what? Here it is, 1 liter. So I am writing V total also here. And total number of moles are how many? Number of moles of hydrogen plus number of moles of nitrogen, oxygen, right? Next, R is constant, T also constant, right? I am writing over like this here. Now, P total we are calculating. What is V total beta? 1. What is number of moles of hydrogen plus oxygen beta? Partial, shall I write in next slide? Better to write in next slide because it is P total. P total I have. P total. Volume I have taken 1. Total number of moles, how much we got beta? How much we got? Here. For this one. What is the volume of the hydrogen beta?
0.5 liters.
I will substitute that one. First of all, I will substitute that one. Okay. First of all, let me see. P total is equal to, again I am writing, no problem. Number of moles of hydrogen plus number of moles of oxygen. Again I am writing into RT. Next, P total. Volume is equal to 1. This I have take volume only. Total volume is equal to 1. Now, number of moles of hydrogen is equal to, we got something. Number of moles of hydrogen, I got something. PV by RT. PV by RT. Okay. Now pressure is equal to what they given? 0.8. Volume is given how much here? 0.5 divided by RT. Now 0.8 into 0.5 how much beta?
4.
4. Correct? 0.4. So I am writing 0.4 RT plus number of moles of oxygen. Again formula will be PVRT. Again pressure of oxygen will be 0.7.
0.7.
And pressure volume of oxygen will be 2 liter divided by RT. 0.7 into 2 is equal to 1.4. So take 1.4 RT. Into what happened? RT. Now again, in the place of 1, I can take PT here. So no 1 here. PT, total pressure is equal to. Now when you take what happened, NCM for this one, 0.1, 0.4, 1.4, we get what actually here? 1.8 by RT. 1.8 by into RT. So RT also will be get cancelled here. RT also will be get cancelled here. Now the P total will be how much here? 1.8. So this will be the answer. Okay. Here it is the answer. Next one, 5.9 we have done 5.9.
No, sir.
5.9.
No, sir.
Okay, let me see this 5.9. The density of the gas found to be 5.46 grams at 27 degrees Celsius, 2 bar pressure. What will be the density at STP conditions? They are asking. So we take a condition for 27 degrees Celsius. We take a condition for STP also. So again, let me show this 5.9 over here. Now STP conditions, at STP conditions, tell me whether temperature is equal to what?
0 degree.
273. Pressure, in the question, they are saying what happened in terms of bar, you see, under the 2 bar pressure, means pressure also you have to take in terms of bar. How much pressure you take, what happened? The pressure, you have to take how much better? 1 bar pressure. Take 1 bar pressure.
1 bar.
At STP condition, pressure you have to take 1 bar here. Okay, now, given conditions, the given conditions will be how much here? Temperature 27. 27 means I can take 300 Kelvin. Okay. Now pressure how much they said? 2 bar here. 2 bar. Now what will be the density at STP? What will density at given? Yes, here density given STP conditions. How much it is? 5.46. Now density given conditions. Density at what temperature? 27 degrees Celsius, the 300 Kelvin temperature we need to calculate.
So at STP we have to calculate.
Now, just the density of the gas is found to be 5.46 gm at 27 degrees Celsius. Okay, this one is given. Sorry. What they're saying, the density of gas is found to be 5.46 at 27 degrees Celsius. How much it is? 5.46 grams. They're asking what will the density at STP they're asking. Density at STP they're asking. So which formula we have to take in this case? So already in one thing we already know, PM is equal to DRT is there. PM is equal to DRT formula is there. Correct or not? PM is equal to DRT formula is there or not?
Yes, sir.
Yes, sir.
One will take for STP, other will take for given conditions. Okay. Now let me see first of all, first equation. STP conditions. One more I am taking. PM is equal to DRT. For what condition it is? Given conditions. That means what happened? 300 Kelvin temperature. Now they are saying but same gas for different gas. For same gas or different gas they are saying. Tell me better.
The same gas.
Same gas means molar mass will be cancelled or not? Cancelled. R will
Yes,
be.
sir.
Now what is the remaining one here? Pressure at STP conditions, isn't it? Pressure at given conditions is equal to density at STP conditions and density at given conditions. Temperature is also different. No, take is one. This is for P1. To take D1, this one will be T1, P2, D2, T2. So take P1, P2, D1, D2. Next, what happened? T1. Now take this formula, you substitute everything, you will get the answer. Now this one will be, you take this one, STP condition, P1, T1, D1. Take what happened, T1, P2, P2, D2. Now P1 will be what here? 1. P2 will be 2. D1 is what? We have to calculate. T1 is what? 273. D2 is given 5.46. T2 is what? 300. Now what will be the D1? D1 is equal to what? 5.46 into 300, right? 300 divided by 273 into 2. Okay. Now you, after substitution, what happened? Calculate this one, solve this one, you will get the answer density. Whatever it may be, you will get that. Understood better?
Yes, sir.
5.10, can you do? 5.10? Possible, no? Which formula I have to take what? Which formula I have to take better?
PV is equals to nRT.
Now take that formula, all of you, and do that one. What will be the answer? Tell me now. All of you do that one, tell me the answer.
PV is equals to nRT.
No, not formula. I'm asking, substitute that data in that formula and tell me the answer better. Sir, Ankes. What is the answer for beta? P is equal to MRT formula. P is equal to MRT formula. But in the question, they're asking molar mass. So you take this formula, P is equal, N is equal to what beta? Weight by molar mass into RT. The pressure is given. How much it is? 1. Volume is given. How much it is? 34.05. But take in terms of liter beta, because R value will take in terms of
Pressure
liter.
is 0.1.
So whenever, remember one thing beta, whenever you are substituting R value in terms of bar or lead ATM, what beta?
Sir, pressure is 0.1, sir.
There is 0.1 bar. Okay, right. 0.1 bar, right. So 0.1 bar. Remember beta, whenever the pressure you are taking in terms of bar ATM, value must be taken in terms of liter. So volume, how much they given beta? Tell me again, volume, how much they given?
34.05.
34.05, convert into liter just by multiplying with what? 10 to the power of minus 3.
Minus
Remember,
3.
when you want to convert into liter, multiply with 10 to the power of minus 3. When you want to convert into ml, हाँ किया सर, अभी 2 मिनट में हो जाएगा. I mean मेरा हो गया होता है 2 मिनट. अच्छा ठीक है. देखो बेटा वैल्यूम कितना होगा? 34 into 0.5. Substitute here 34.05 into 10 to the power of minus 3. Now weight, how much they given beta? 0.0625. 0.0625. Molar mass we need to calculate. R value is, I told you, bar 0.08. Because pressure, when you take bar, pressure we are taking in terms of bar means R also should be taken in terms of bar, 0.083. Temperature 546 degrees Celsius.
819 Kelvin.
So add 270. 8, 9 here, 11 here, 919 Kelvin temperature. Now you'll get everything. Set mass.
819.
Is better? 11,
The
4, 11.
819.
8, sorry. 5 to the 7 plus 8, sorry. Now send this mass over here, you will get the answer, right? Understood here?
Yes, sir.
Remaining
Yes,
problems, you do remaining problems, whatever you will get remaining, you have to do that one. So if you have any doubts, you can ask me now. Okay? Otherwise, you try remaining problems. I think 2-3 problems you have done in the last class. Remaining problems also 2-3 problems you have done in the last class, I think. Okay? So whatever the problems are there, leave it the 5.21, sorry, 5.22, 5.23, no need that one. Right? So today what you have to do better? So whatever the remaining problems are there, try all, and tomorrow we'll start thermodynamics, right? I think in your class you have given the link to somebody. Your class, whatever the 11th class A Google link, G Suite link, you have given somebody. That is the reason they want to join. So that जो चोर है ना आप ही क्लास में है, जो लिंक दिया आपका क्लास में, जो लिंक कहाँ से आपको नहीं मिलेगा, जनरली लिंक तो नहीं मिलेगा ना किसी को, इट इज इम्पॉसिबल। तो आपने ही दिया और लिंक, इसके वजह से तो बाहर लोग आने के लिए यहाँ पर कोशिश कर रहे हैं, राइट? ओके बेटा, how many students are there today? Only 54. Shall I take attendance? Just a minute, I will take attendance better. You wait for 2 minutes. अभिषेक शर्मा, हॉटस्पॉट नहीं चल रहा है, आ रहे ऑन हो गए सर, दिस ऑलरेडी कैच नहीं कर रहे।
प्रेजेंट सर।
नहीं है सर,
या तो डिस्टेंस की वजह से नहीं कर रहा हूँ।
अभिषेक शर्मा, अभिषेक वाई,
प्रेजेंट सर।
आदित्य, अंशु,
Present, sir.
Present, sir.
अनुज, अनुष्का, अनुष्का,
Present.
where you
Yes,
went?
sir.
Last 3-4 days you were absent. No
So
permission.
actually, where I have shifted, there is a network problem.
You didn't ask any permission also. You didn't take any even permission also. Now you are seeing that one network problem.
So I have trying to connect it, but it is not connecting.
You didn't inform me. From last 4 days you are not connecting and you didn't inform me also. That is not
Sorry, sir.
valid reason. Atharv,
Present, sir.
Ashif,
Present, sir.
Apurva, Atul Rawat, Balmukh,
Present, sir.
Present, sir.
Dhanshri,
Present, sir.
Jnanesh, Deepta,
Present, sir.
Jnanesh,
Present, sir.
Kalpesh, Kaush,
Present, sir.
Present, sir.
Krunal, Manoj,
Present, present.
Ojas,
Present, sir.
Omkar DM,
Present, sir.
Omkar PC,
Present, sir.
Samiksha,
Present, sir.
Pradmesh,
Present, sir.
Raghav,
Present, sir.
Rahul,
Present, sir.
Raj, Ramya,
Present, sir.
Priya,
Present, sir.
Sahil, Rohit,
Present, sir.
Samruddhi,
Present, sir.
Sarthak,
Present, sir.
Samruddhi present. Shashidhar, Srihari,
Good morning.
Present, sir.
Sneha ji,
Present, sir.
Sneha VS, Sneha VS. Again, she is absent. Yesterday only I told her. Sonali,
Present, sir.
Sumit,
Present, sir.
All beta, you join. I will join within 2 minutes.
Sumit SD,
Present, sir.
Suraj,
Present, sir.
Suraj C,
Yes,
Suraj
sir.
U, Suraj U, absent. Priyambak, absent. Umesh,
Present, sir.
Vaishnavi N,
Present, sir.
Vaishnavi J, Vaman,
Present, sir.
Vedant,
Present, sir.
Present, sir.
Present, sir.
Yash,
Present, sir.
Swastika,
Present, sir.
Tejaswini.
Present, sir.
I'm just reading the names of absentees, beta. Triyambak,
Good morning to all.
absent. Suraj U, absent. Gulabi, absent. Gulabi, absent. And finally, Ayush, absent. Okay, beta. You can leave now.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Good morning.
Thank you, sir.
Thank you, sir.
Sir. सर
हाँ बेटा.
सर आपने मेरा नाम ले लिया सर मयूर.
मयूर आपका अटेंडेंस दिया बेटा. आपका ये इसमें डिस्प्ले पे आ रहा है ना, आपका नाम मैं दिया. मैंने नाम इसमें देखा, उसको दिया. कोई प्रॉब्लम नहीं अटेंडेंस.
यस सर. सर मैं सॉरी सर. हाँ सर कल एब्सेंट था थोड़ा.
ओके.
हाँ सर. यस सर. थैंक यू
ओके
सर.
ओके.